So today we're going to talk about atmospheric properties. But we got to do a little review. You guys remember way back to week 1?
Yes.
When we got that periodic table of elements out and we were messing with building the molecules and all that, and we also talked about states of matter. Remember we had those big jars full of balls, okay? Does anyone remember, raise your hand if you can remember what one state of matter was. What was a state of matter?
Laws of motion.
No, well we talked about laws of motion, but we're talking about states of matter. Donovan?
Plasma.
Plasma was one. Yes, that was our fourth one. Plasma was a state of matter. What was another one? Gases. What did you say?
Solid.
Solid. So we have solid, we have plasma, gases. There's one more. Kenneth.
Liquid.
Liquids. Okay, so we have solid, liquids, gases, and plasma. There's some things we need to know about our states of matter. Okay? Now solids. Is this table a solid?
Yes.
Okay. All right, so it has a definite size. Okay. What about a definite shape?
Yes.
Yes. Okay. So solids have definite sizes and definite shapes. Okay. Now, liquid. This liquid here, guys. I've got liquid in this. If you look at that, look at the shape of it. Does that have a definite size, that liquid? Could you measure that? Does it have a definite shape? Oh, Takaya says it could change shape. How could I change the shape of this water?
Because if you say you put it in that cylinder,
Okay.
It would change shape to a cylinder.
That's exactly right. Okay. Liquids have a definite size. They're measurable, but they don't have a definite shape. It takes the shape of whatever object I put it in. If I dump it in a bucket, it's going to take a different shape. But it does have a definite size because you see how this bottle's almost full of liquid? Okay, what if I fill this cup up here? Now, can I put all of the liquid in this cup, in this bottle?
No.
Why not? What would happen?
It would overflow.
It would overflow. I can't cram all this water into this bottle because the liquid, it has a definite size. So I can't fit it all into here. What I want you to remember about liquids is they have a definite size, but they don't have a definite shape. Like Takaya said, whatever you put them in, it'll take that shape. Gases are a little different. Think about gases. Now, is there gas in this room right now?
Yes.
Air. There's air in this room. Is it filling this room?
Yes.
Okay. All right. So it's taken the shape of this room. Is there gas in that room over there?
Yes.
Okay. It's a different shape than the gas in this room, right? Because it's a different shaped room. Okay. Now size. What about size of gas? Do you think it has a definite size? This is how I like to think about gas in size. Have you guys ever seen that like brown helium cylinder that they fill up balloons with, like like a price chopper or something you can go in, and or anywhere where they put that balloon on and it goes and it fills the balloon up, then it'll float, right? Okay, now, that cylinder is full of helium gas, okay, and that cylinder, guys, is about this tall, right, and this big around and that tall. So can you only fill up a balloon that's this big around and this tall? How many balloons can you fill up?
Like 10,000.
Bunches of balloons, right? Because this is what they did with that gas. They took this much gas and they crammed it down to fit in this. Because gas doesn't have a definite size, okay? So they can cram it down and fit a bunch of it into that cylinder, and then they can let it out and fill up balloons. Now, shape-wise, can you fill up a round balloon?
Yes.
What about a long balloon?
Yes.
What about a balloon shaped like an alligator?
Yes.
What about a balloon shaped like a heart?
Yes.
Okay, what about a square balloon?
Yes.
Okay, so does it have a definite shape? No, it will take up the shape of any container it's in. And what about size? No definite size, right? Because we can take, how much gas can we take? This, and we can cram it down into this, right? Everyone do that. This much gas, and we're cramming it into here,
We did
okay?
the same thing twice in Hollywood's room. We sat there and kept going like this.
Oh, well, do you guys have one of these in your classroom?
Yeah.
Okay. All right, the globe shows our planet, right? Okay. Now, we've got landforms on this globe, right? You see these landforms? And we've also got bodies of water. We've got oceans, we've got lakes, we've got seas. Yes, sir, do you have something you need to add?
States and countries.
Right.
And
We've got
clouds.
Yes, we've got
And
all that
also,
on the globe.
I
Now,
think, I remember from a couple days when we came here that there's a hemisphere, a northern hemisphere, a southern hemisphere, an eastern hemisphere, and a western hemisphere.
you are correct, sir. You are correct. We talked about our states of matter that we're going to talk about today. We're talking about solids, we're talking about liquids, we're talking about gases. All right? Now, we all live in Kansas. So here we are. We found North America. We found Kansas. So we're all living here. Okay? Okay, right there. So what state of matter, if we're talking about our solids, liquids, and gases, what state of matter does our landform represent? Raise your hand if you think you know if it's a solid, a liquid, or a gas. What do you think there, Dante? A solid. So our landforms are going to represent our solids here. All right? Now, what state of matter would our oceans represent? What do you think there, Dacia? Liquids. All right? Right? They're water. They're oceans, seas, lakes. They're all water. So they represent a liquid. Now, there's one more state of matter that isn't represented on here. Donovan, what isn't represented?
Gas.
Gases. Right. So our gases are not represented on our globe, but they're around us. You guys said this room was full of air. Okay. Do you know what we call the gases that surround our planet? Mateo?
Equator.
No, that's the equator. That's an imaginary line around it.
I know.
Malaysia.
Air?
Okay, it is air, but we call it something else. It might be written somewhere, possibly. Kenneth?
Oxygen.
There is oxygen in our air, yes. Zoe? Gravity is a force that holds us to this earth, and we're going to talk about gravity in a minute. Okay, I'm going to give you one more hint. It's written all
Atmosphere.
over.
Atmosphere.
Okay, atmosphere. Okay, it's called our. Have you guys heard that word before?
Yes.
Yeah, you've heard atmosphere before. Okay, the atmosphere. Okay, so what I'd like you to do, let's look at the. Go ahead. We're going to write. If you look at the top of the top of page 21 here, on 1, 2, and 3, and I'm going to back this up. I want you to write solid, liquid, and gas on 1, 2, and 3, and go ahead and add a number 4 and write plasma. They're all written up here on the board just so you can see them. Solid, liquid, gas, and go ahead and add plasma to that list. It's at the very bottom. Let me put this laptop down. There we go.
Hey, I can't show your pencil.
Oh, well then write it on down. Yeah, you can't see. Hurry up. Just like that. There's a couple of statements. You guys see where it reads ocean of air? Just under that on your flight log there, Haley, on page 21. Okay. It says ocean of air. Now, it says the atmosphere is a blanket of blank that surrounds our Earth. It's a blanket of what? What were we just talking about? It's a state of matter. A blanket of what that surrounds our Earth? Tatiana says gas. Okay, so go ahead and write that down. It's a blanket of gas that surrounds our Earth. Okay, now, why? Now, can we see air?
No.
No, but it's there, right?
Yeah.
The particles are just so small that we can't see it. Let me ask you this. Why doesn't our atmosphere, why doesn't it just float out into space? Why do you think it stays around the Earth? What keeps it from floating off into space?
Gravity.
Gravity. Okay? So on your next line there, that's the force that holds it in place. If we didn't have gravity, it would just float away. What else would float away?
We would float.
Donovan?
We
would float away. Everything would float away. Okay? So not only does gravity hold us to the planet, it holds all our chairs and our tables and our buildings and our dogs, it also holds our atmosphere, our air. It's time for our spatial awareness time. You guys have all seen a pie chart, correct? Okay. I like to call it a pizza chart. Now, if you look on your flight log there, or up here, you've got 3 different segments, right? We've got a little sliver, then we've got this wedge, And we've got this Pac-Man. Now, Nautica, how many percent is this whole pizza? The whole thing. 100%. So Nautica said that our whole pizza up here is 100%. Okay? So if Christian eats half my pizza, if he eats half of it, how many percent do I have left? 50%. Okay, so if half of this was 50, let's look at this big blue area. What percent, raise your hand, what percent do you think that blue area might be, Tatiana? 90? It's less than 90. Okay, Damien? 76 is very close, but it's too low, and 90 is way too high. Okay? 80 is too high, so now we've got a range of 76 to 80. Amy? 79 is very close, but still too high.
I know.
Kenneth?
78.
78 is exactly right. Okay? So that is 78% of our entire pizza. Okay? Now, I want to ask you this. What gas do you think that... This is our air. This represents basically our air, our atmosphere. Do you guys have a guess at what gas that is? What do you think, Kenneth? Oxygen. Oxygen's a great guess. Why is it a great guess? Donovan? We breathe oxygen, right? And when I was in 4th grade, that's exactly what I would have said too. But it's not. It's actually nitrogen. Okay? So if you look on your little table here, there's nitrogen there. That represents the blue. Okay? I want you to write 78 in that little box there. Okay? On your table, go ahead and write 78 particles. Right there on that little box, right next to nitrogen. 78. Right here. Right there. Right here on this particle for nitrogen, right? 78. Okay? Now, you guys remember week 1 when we had the periodic table and we built all those little things, the little molecules? Okay? The reason there's so much nitrogen is because nitrogen doesn't like to bond with things. Okay? So there's a lot of it in its natural state in our environment. Now remember, oxygen did like to bond with things. Okay? Like, remember it bonded with something else and we call it H2O. Does anyone remember what H2O is?
I do. Water.
Water, right? Do you remember what the H stood for? What gas that was, Kenneth?
Oh, hydrogen.
That was hydrogen. How many hydrogen did we have?
2.
2, because it's H2. How many oxygen did we have?
1.
Just 1. H2O. So, okay. Now, has anyone heard of carbon dioxide?
Yes.
Okay. Has anyone ever put hydrogen peroxide on a cut, that stuff that bubbles up?
Yes.
Okay. Have you heard of iron oxide?
No. Yes.
Some people yes, some people no. How about this? Have you ever heard of rust?
Yes.
That's iron oxide, okay? So anytime you hear a substance that has an oxide after it, carbon dioxide, what will they do? Breathe out. That has oxygen attached to it, okay? So anything with oxide in it has oxygen molecules in it. So it likes to bond with things, okay? So let's look at that's our red section of our pizza here, okay? Now, we had 78% of our 100 taken up with nitrogen. How much do we have left here of the oxygen? 5%. It's more than 5%, Mateo.
22?
22% is so close, but it's too high. And 5%, this is our range, between 5 and 22. Kenneth? 21% is exactly right. Man, he's our man here on the, okay, 21%. So write that in the next little box down next to oxygen where it reads red on your little table here. Write 21. What I'd like you guys to do over here beside your pizza or pie chart, right over here, I want you to add, write an addition problem, 78 plus 21. Okay? Go ahead. Well, I want or just over here, anywhere on your paper, it's like it's scratched. Okay, hold on, we're gonna. Okay, everybody got it added up?
Yes.
Marco, how much is it? 99. Does everyone agree with Marco? 99? Okay. All right, now, if we had 99% of our pizza taken up now, What do you think that's what little sliver? How much do you think that guy is?
1%.
Tariana. 1%. Okay, so go ahead and write that on your third little box down on your table. 1%. That's our other gases. This is our carbon dioxide, our helium, our all hydrogen, all these other gases. They just lump them all together into that 1%. Hi, Tony Hyde here. This is lesson number 2. Mine was over an introduction to atmospheric properties. My objective was to use differentiated instruction. My first objective was to discuss how use differentiated instruction for the lesson for individual and distinct groups of students. I had to, mainly for the whole group. This is a 5th grade science curriculum, and this was a 4th grade group, and they're economically disadvantaged school, and so they were a little on the low side for where they're at in 4th grade right now. On top of that, so I adjusted the way that I presented some of the information. I added some visual aids to try to help them, like for instance the water bottle and the cup to represent liquid having a specific size, and that seemed to work pretty well. I also used an actual globe instead of the PowerPoint like I normally do. I just normally cover it with the picture on the PowerPoint. I brought the globe out. There's some kids that have real short attention spans and have some behavioral issues. So having the globe out for them to look at it seemed to keep them more engaged. This was something small, and I've noticed it with some of these, especially economically disadvantaged schools, that using the pizza instead of the pie chart, they seem to understand it better, I guess, because they're more familiar with pizza. So for some reason, just on their spatial awareness, they do a little better when I refer to it as pizza rather than pie. I also had them write down the addition problem, the 21 plus 78, in their books, which I don't normally do. Most of the students can just, they're just going to add it in their head using mental math. But I had them all write it down, and everyone gave them time so everyone could solve it. It, helped keep them engaged, and made sure everyone was paying attention and everyone, got the right answer. I also pointed out specific places on their table that they had to fill out. And walked around tables and pointed out to specific students that still weren't sure where they needed to write information down. And then on PowerPoints, also I made sure the PowerPoint was up with any writing they had to do because spelling was an issue with this group of students. So I made sure that was up and that they could read it and copy down what they needed to write down. My second objective was to discuss any challenges that arose related to differentiated instruction either during planning or implementation and how I handled those. Again, it's the biggest challenge, and it was all really no challenges arose during. It was mostly in the pre-planning, but that was how to meet the objectives of my lesson, but still keep this 4th grade engaged, as younger students, keep them engaged and learning something. And so that was challenging, but like I said, it was all on the front end in the planning. I really didn't have much trouble during the implementation. Nothing really arose then. My third objective, discuss how you'll change your approach in future lessons based on what you learned from this teaching experience. My pacing, which I've always had issue with, and I'm getting better and better, but my pacing was a little slow. And I guess this was a problem that arose. This could go back to that things just took a little longer with the 4th grade in discussion. Everything's just a little bit slower. So I need to work on my pacing for a younger group like this. And also, I noticed that some of the students towards the end weren't quite as engaged, and so I think that maybe if I can get a little more hands-on stuff going for them, and or maybe just a few more, things they can write down to help keep the
keep them reined in and engaged in the lesson. I think that will definitely help me in the future, and I will be working on that. I hope you enjoyed my video. Thank you.